It's great to see everyone here. Thank you for joining us. Once again, we're in week 3 of the hackathon, which is really exciting. So much content that you've all had access to and hopefully giving you lots of ideas, thinking ahead to your builds and what projects you might like to work on. So yeah, thank you for coming along, getting the first-hand kind of experience. Of course, all the sessions are recorded, so if you don't get anything first time around, do not worry. You can watch it back as many times as you like, just to make sure you've covered all the content properly. But I think that's all the notices from me, so I'm going to stop taking up too much time, and I'm going to hand over to Junda from the Brevis team. We're really excited for the workshop today. So yeah, Junda, thank you for joining us.
Yeah, thank you, Roy. Really happy to join the Encode Hackathon. I think in the opening session, I had like 1 minute at most to introduce the project. I hope I did a good enough job so people will get interested. And of course, today I will spend, I would say, 30 to 35 minutes to go through both like what exactly we're working on, why we're doing this, and also as a developer, how Brevis can enable completely new use cases and the features the app previously couldn't have, right? And hopefully, and of course, in the last of my talk, I will go over some of the brainstorming ideas, hopefully to give more developers some interesting perspective. Oh, with this new capability, now I can do so much more. Okay, Brevis is EigenLayer's first mainnet launch partner. If you check the what's the EigenLayer AVS website, I think now we are by the TVL we are number 4. Last time I checked, we are number 2. Now I think it's really competitive, but it's still very close. And if you click the project, it will say Brevis is a smart ZK coprocessor, right? I would say first, unlike layer 2 rollup, people are not really familiar with this kind of relatively new term, at least in crypto industry. It's more like a borrowed term from the hardware world, like GPU, right? The graphics, NVIDIA, right? The GPU is the most famous coprocessor. And the way we kind of describe it is, oh, what we are doing to the blockchain, right, to your smart contract, is similar to what a GPU does for CPU. Right? You will see it's more obvious as I go into my talk. Okay, and now I just close it and switch to the talk. We can the kind of take it a little bit back. So we have been in this field for really a long time, and since the white paper of Bitcoin, we have seen so much improvement over all kinds of aspects, right, for the blockchain to be more, I would say, user friendly, increased performance, and everything you can think about to really make it ready for mass adoption. But there are still some fundamental limits we cannot easily overcome, right? Because as long as you still rely on a decentralized distributed consensus, the blockchain environment, basically the on-chain environment, is very restricted and limited in what they can do and what data they can access. This might sound a little bit, high level. Is that what exactly are you talking about? I'll just give you a very concrete example so people, I would say, most of people immediately get, yes, exactly, that is an obvious problem. It's just we pretend it's not, right, in the past. Think about a trader loyalty program. Right? If you have ever used any of those centralized exchanges, it's a must-have feature since day one, right? I've never heard of any centralized exchanges that didn't have a trader loyalty program. Basically, it will give you some incentive, like fee rebate, like a reward based on your, say, last 30-day trading volume, which is, makes perfect sense, right? If you think about this way, all the platform want to kind of retain the loyalty, high-value traders. But if you look at a DEX, right? None of the DEX had it until last month when we announced the partnership with Uniswap. Right? Why? You say, hey, how hard it can be. If you think about on the high level, what you need to do is you remember for every user, right? Remember the past trading trades, like say it could be 10,000 trades over 30 days, and sum over the trading volume. And based on the volume, the protocol might decide to give a different, say, VIP tiers, right? Like gold, platinum, diamond, and then give them some fee rebate as an incentive. Excuse me. But it turns out if you want to do that purely on-chain, it's super, I would say, ridiculously expensive, and basically it takes push. Most projects say no, we cannot afford this. This 4 hours and at least $20,000 purely in gas fees is saying, if you want to do this purely, like completely within your smart contract, right, written in Solidity, say, I will remember all the trades, and after that I will sum over 10,000 of them. You will occupy a full 4-hour window of all Ethereum blocks. So that's how much gas you need to pay. And I would say the $20K in fees is too optimistic. It's way more than that. So you say, why you have it's such an expensive thing to do? Because remember, within your so-called smart contract environment, it doesn't even see any history, right? It can only see what's available at that block. So how do you prove something happened in the past? You have to remember the previous block, basically the state root, of course, all the way hashing to the block header. And then for 10,000 trades, you have to calculate the 10,000 Merkle proofs. The good thing with blockchain, right, to give them credit, you have to, the benefit is every single piece of data, you can verify it. The verify itself, if you try to do it purely, say, in Go Ethereum in an off-chain environment, is nothing, right? Just run the hashes and all the way calculate the Merkle root, and you're done. But doing that within your smart contract environment, you can try, right? People did try. I'm not saying like people didn't try, but there are many, I would say, half-baked projects you can, or code examples you can find on GitHub that try to do these kind of things, but all of them give up because it just, the cost is prohibitively expensive. It's just not sustainable. Right? And don't forget, when you say, hey, I want to know this piece of data, within the underlying the EVM, right, within their world state, every leaf node in the Merkle tree is stored with RLP encoding, which surprisingly or unsurprisingly is actually not very efficient. If you go into the detail of how they do the encoding, there are many zeros, and basically I would say in the first design, the focus is more on canonically, right? Basically, they want to make sure there's never an ambiguity in decoding, and they have to add more and more metadata into the finalized serialized format. But the cost is whenever you try to decode a piece of data, it's also very expensive. And after say you have done all this, don't forget the number we want is a simple number, say what's the past 30-day trading volume, right? It's a total sum. It's a simple sum. But as hopefully I already convinced you, do not even try to do this on mainnet. You can try to play with it a little bit, but don't try to do it because the cost is just so prohibitively expensive that it doesn't make the whole thing make sense. So now that we seem to kind of stuck here, right? So if you say, hey, the on-chain environment, how do we even support this kind of so useful use case, right? All the centralized exchanges had it not because they want to have it, because they must have it to have this, like the loyalty user retainment, right? But then if you say I cannot, because of the limitation from the on-chain environment, we cannot have this historical access, data access, or computation. Now, what are we left with? we are left with exactly, I'm not saying that there's no amazing dApp can be built, but if you look at, we are always joking, your smart contract is very dumb. Why? It doesn't even have a database, right? So think about someone come to you and say, hey, I have this amazing idea to write a financial application, but there's a catch, there's no database. I would say most people were laughing out, like, what are you talking about? It's ridiculous. But in this, I would say Web3 environment, if you reflect, and it is true, right? Think about Uniswap. Even if you are a big whale has done like millions of trades on Uniswap, every time you interact with their contract, the contract doesn't know, right? The contract doesn't even care. They will treat you exactly like a brand new user address, right? For the first time interact with Uniswap. So I think that's kind of why, from Brevis perspective, we say, hey, it seems there's so obvious there's a gap here. Again, right? The coprocessor is not trying to feel like the traditional layer 2 or rollup, which are more in the scaling game, right? Basically say, hey, what's your TPS? My TPS is 10 times higher or something. No, we're not trying to compete in that track. Instead, we're saying, hey, everybody is talking about the historical on-chain data is a gold mine, and it seems to us up until today, it's just lying there. No one really can leverage the insight, right? Yes, there are like Dune or some other data analytic platform that can give you very pretty dashboard. But if you think about that, how can you turn those insights into action, right? So I think in the data analytic industry, people talk a lot about, so yeah, you have big data, you have fancy ML, machine learning algorithm or AI, and you have some very powerful insight, but you do not stop there, right? You have to turn your insight into action. But I think that is still missing, right? This basically say, even, of course, Uniswap has all this kind of dashboards for their traders and the trading volume, everything. But how do they turn those insights? Basically, how do you make the dashboard actionable, right? You know the result, but then how do you do that within your smart contract in a trust-free way, right? I think that's kind of the whole ZK coprocessor trying to enable. So basically, we are enabling a much more data-rich and complex computation for on-chain application. Within your smart contract, before it can only deal with what's available within the same block at that transaction. If you think about it, it's a very, very restricted and very, very limited environment. But now with the ZK Magic and the projects like Brevis, the on-chain application can literally access any piece of data it wants and also run arbitrary computation. So, but another part is people familiar with Oracle will say, hey, don't we already have something very similar? Right? I think the key part here, because it's all based on the zero knowledge proofs, we're not introducing any new third-party trust. It's not like we have another committee. You have to put additional trust on those committee members are all behaving honest, right? So because the final correctness or integrity of the data is guaranteed by the underlying math and your code, which is just like any blockchain, right? You have the underlying math in there, and then assuming your code has no bugs, the consensus is correct, right? You do not need to trust anything. So I think that's kind of the high-level takeaway from the ZK coprocessor perspective, how we can enable, right? So, and I think that's the try to convince everybody the blockchain environment or execution environment we have today is limited, and we are confident it will be still limited as long as it's a truly decentralized environment, right? Because of the limited bandwidth and also the global communication overhead. It can never be as performant or as cheap as running on a single database server. So that's why the ZK coprocessor can fill this huge gap and enable completely new paradigm. Again, we're not in a scaling game, right? It's more like, say, we are enabling so much more new use cases. It doesn't have anything to do with scaling, right? It's more about suddenly with the access to the full historical on-chain data, and it doesn't have to be the same chain. It can be any different chain, right? like say a new DEX starts up who knows, base, and it actually can say, hey, I want to attract the loyal users on Ethereum mainnet, right? So I think that's all because ZK coprocessor is inherently omni-chain. It doesn't it's chain agnostic. From a dApp developer perspective, you don't worry about it. Basically, you said, excuse me, whatever the data you're interested in and what kind of the computation you want to do over that. And the Brevis framework, of course, with Brevis SDK, you will write your own piece of code, and the Brevis underlying infrastructure will handle that. Yeah, sorry, get some water. Yeah, I got a bad cold last week. I literally lost my voice 2 days ago. Good thing it's today morning. It was yesterday I couldn't even speak.
Well, you're doing a great job so far. So
yeah. Okay. So I think hopefully by now I've already convinced you. Yes, at least this makes sense, right? So basically, we know the on-chain execution is expensive, is very limited, but with the coprocessor, ZK coprocessor, without compromising the trust-free property, we can enable many new use cases, just like the Uniswap, trader loyalty program I mentioned earlier. And up until now, some people might be asked, kind of have the question back up in your mind, say, hey, where is the EigenLayer play, right? So bear with me, right? I will go through the which industry or which gap we try to fill, and then I will go through, if you want to benefit from Brevis system, how you write your dApp together with Brevis, and then I will talk more about how or why we actually work with EigenLayer. Because when I usually stop here, people say, hey, don't you say you are not introducing any new committee, but why you work with EigenLayer, right? I think that's always a fun question. Yeah. So next, I will go through how you, as a dApp developer, how you can benefit from the Brevis system, right? So on the high level, you can view Brevis as kind of a utility or toolbox that can generate ZK proof of arbitrary computation on any data. So here, again, right, up until now, I've been always using the historical on-chain data as example. But it doesn't have to stop there, right? It's just like this is the, I would say, low-hanging fruit. It's so that it's like there's already so much information out there. It just waits for people to be able to like develop insight and action on it. But internally on our roadmap, of course, we are looking at data that's beyond simple blockchain, right? It could be anything else that can be ZK proof and ZK verified. And then within your on-chain smart contract, you can utilize this computation result, just like the trading volume. As a sounds like a simple sum, right? Over 10,000 different trades. And then within the smart contract, because the result, the underlying data, and both the underlying data and the computation results are ZK verified. So the smart contract can use it in a completely trust-free way. So as a developer, there are simple 3 steps, right? First, read, basically to tell us where are the data, which are the data you are interested in. And the second step is do your computation. As I say, hey, is it a simple sum, or you want to do something fancier like calculate the mean or whatever it's more like towards the traditional data analytics or big data or data scientist world. Say, hey, what kind of insights I can develop from this kind of data, and even of course supporting primitive like UDFs for machine learning use cases. And the final step 3, verify, happens on chain, right? And of course, this part of the code is handled. The actual ZK verification is actually handled by the Brevis core contract. And later you will see within your own smart contract, you only wait for a callback, which actually is pretty straightforward. So what are the data today, right? You can access. So all the, for EVM compatible chains, the story, basically the the storage slots, transaction receipts, and all the block information. So basically, it's everything available, part of the chain, part of the word state, part of the block header is all there, because we actually run the underlying infrastructure to make sure the consensus checkout. Basically, it's a POS. We have to verify the signature, right? BLS signature for beacon chains and all the aggregate, everything is correct. And then block by block, right? Every piece of data will hash to the block header. And as I mentioned earlier, we support different, blockchains, and especially when the new partner come to us and say, hey, like I think Trust Labs came to us, say they want to do some like similar to credit score. Basically, they want to calculate a score for different address based on its past activities, and they want to run it on linear, and then we spin off the environment. Within a day, they can do everything on linear. And this is our Go SDK. And of course, for people more familiar with TypeScript, now we are also offering a TypeScript wrapper over the underlying Go code. The reason we choose Go is mostly for the performance reason. Later on, I will give you some data points, because we also got this question a lot. Say, hey, did you use any of the ZK VM or ZK DSL solution? And our current answer is always, we tried and didn't work in our case. So we have to kind of handcraft all the underlying ZK circuits with the most performant system we can find, right? And as a developer, the SDK, the Brevis SDK, hides all the underlying ZK complexity, right? You don't need a cryptographic PhD to be able to write this code. It's just more or less what are the data. Like here is the example for Uniswap. It just look at the log field, right? Basically the trading volume, like for every trade, for every swap, the amount will be in the event. So basically in Ethereum term, it's in log, right? The log data. And you just tell us, hey, what are the log you are interested in, which are the fields. And then the step 2, you write what are the computation you want to do, right? Because as Brevis team, we can never guess what you want to do. As a developer, oh, for the trading volume, I'm doing a sum, right? And we kind of recognize this pattern. So our API is literally, we add this like MapReduce style data analytic, APIs. So you don't even need to write your own loop to go over, say, 10,000 trades to do the sum. You can just write receipts.sum and you're done, right? So I think that's the power. We are giving the developers a high-level API to express their intent, or basically what they want to achieve, instead of kind of tangling with the underlying implementation details. Oh, you have to be aware of this is loop, and then even writing a loop, you have to have fixed all the underlying, I would say, ugliness of the ZK is, basically abstracted away within our SDK. And finally, within your code, you will say, hey, what are the final result I want to output, right? So here you output the final volume and the block. So basically, these are the example, right? So basically, for the trading volume, you also want to make sure your address include so the result include the user address, right? So you can do one-to-one mapping. And now this is the final step on the blockchain. This piece of the code called handle proof result will be implemented within your Solidity smart contract. And this call will be called by the Brevis core contract after we have verified, okay, the ZK proof is legit, everything checks out. This is the result. We're past basically whatever. Remember in previous slides, your code will output some of the results, right? So here output uint, output address. And we'll basically concat all the fields together and pass you as a circuit output in this function callback. And within your contract, you will do some simple decoding and get the volume, minimum block number as an example, and the user address. And then next step is up to the developer to do what they want, right? Basically, with the Uniswap example, they were just based on the trading volume, give the user a different tier, and then based on the tier, when next time the user does some trade, they can get a fee discount. I briefly mentioned, why we choose to go this way. Yes, there are similar projects kind of see the value, what we are working on. And even some of the projects, maybe previously, they didn't brand themselves as ZK coprocessor. Now they jump on board and say, yeah, we are also a ZK coprocessor. I think we, as a Brevis team, we are pride in that we are production ready. We already launched the pure ZK and everything with a very reasonable cost control, because we try to squeeze every bit of performance from the entire proving stack, right? Honestly, zero knowledge proving today is still very expensive, right? We have to use like special like NVIDIA GPUs, very powerful ones, many of them to run the parallel computation so that it can be done within a reasonable time frame. And all of those cost money. And adding any of the additional layer of abstraction, it could be DSL, it could be VM, right? Easily make it at least 50 or even 100 times slower. So that's basically some of the costs. We say, hey, if we want to be serious in production with and working with all the large scale partners, they are not just doing a hello world example, right? They like Uniswap came to us, hey, I have this big trader that has done literally 10,000 trades. Can you do that, right? That's kind of because of the underlying system performance. That makes us to say, yes, we can handle this kind of the data scale. So basically the scale and the cost efficiency is what makes Brevis, stand out. And in the production ready, and on all those kind of mainnet launch, like Be with Trust Labs and all the other DeFi partners, that's why kind of we can handle all this super complicated and large scale data set with a reasonable cost, right? Yes, you will say, hey, wouldn't the big whales on Uniswap anyway willing to pay? Yes, right? Our cost is at most $10, but they can, with this proof, they can claim back hundreds of thousands of dollars in fees, right? So they are more than willing to pay. But on the other side, there are also other applications or use cases. It could just be some airdrop, some NFT ownership thing that couldn't afford more than say $50, right? So we actually talked with some of partners in the beginning, and they say, hey, if a proof cost $10, but the whole reward is not that much, how no one will do that, right? So that basically is not a sustainable business. So that's actually come to a different perspective why we need EigenLayer. There are basically two parts. One, pure ZK is still, costly, and there a second reason that many of the projects in the field don't like to talk about this. Pure ZK has its fundamental limit. Zero knowledge is very good at proving something exists, something happened, but it actually sucks to try to say something didn't happen. We had partners came to us say, hey, can you prove this address or this user never say interacted or used Tornado Cash before? Intuitively, you say, hey, that sounds like a very reasonable request. But if you see how you, in the pure ZK mode, how you can do this, it actually turns out to be very, very expensive because, again, ZK cannot prove something didn't exist. So they have to prove all the transactions from this address. Basically, it's unbounded, right? It could be go to hundreds of thousands of or even millions of transactions from this address. All of them, the interacted contract, basically the destination contract, is not Tornado Cash smart contract address, right? Which is of course not so scalable, and basically no other coprocessor can handle this if it's a pure ZK mode. So that's why we work closely with EigenLayer team as one of the first mainnet launch partner to launch Brevis coChain. coChain, you can think about, is a hybrid mode, right? Yes, we will benefit from the EigenLayer's vast risk-taking community and the operators and the risk-takers to add the crypto economic incentives. On the other side, because we always have the final ZK as the ZK proof, right, is always there, ready to be submitted. So we are not saying with this additional committee, we get all the benefit, but we're not introducing additional trust. Why? Because if all of them, or I would say more than 2/3 of them behave maliciously, any person can submit a ZK proof to say, hey, I have the mathematically correct proof that of more than 2/3 of the committee members lied, so they get the reward, the slash token as a reward. Right? So on the high level, go back to the Tornado Cash example. Instead of saying this, instead of trying to prove all the transaction this address has done, with EigenLayer's committee, they can all agree, say, hey, we all agree, and they co-sign using EigenLayer's signature aggregation, say, we all agree this address didn't use Tornado Cash before. The next question is, what if they lie? For anyone watching this, right? So yes, we do introduce roles like watchers or we call watchtowers or what is called monitors. There are different names for them, right? And they will say, hey, if they could find that single transaction, so now we turn a fundamentally unbounded problem to a single transaction proof, which is, again, at least today with single transaction proof, you can literally do that within your browser, right? It takes about a minute or two. So there are people can helping securing the network, running the monitoring code and say, hey, I disagree with the co-signed result. Remember, we focus a lot on saying that with ZK coprocessor, we are not compromising the trust-free nature of the blockchain. Right? So basically, even though we ask the committee members or the EigenLayer operator to co-sign a result, we don't have to put all our trust on them. Right? We can say, even if more than 2/3 or whatever threshold of them behave maliciously, anyone can submit a ZK proof to prove them wrong. And that proof becomes much simpler and much easier. Instead of proving all transactions, we flip the coin. You only need to prove that single transaction this user has done, right? Has interacted with Tornado Cash. So I think that's the kind of the power. I think even up until now, Brevis coChain is still the first and only hybrid ZK coprocessor, leveraging the crypto economics for the efficiency and in the optimistic path, it's also much lower cost. Right? Basically, with the cosign, there is no ZK proving incurred. And on the other side, whenever a challenge ZK proof need to be generated, the watcher or the challenger has all the incentive to do that. Right? I would be willing to pay a minute of my laptop time to claim a slash token, right? That sounds a too good deal to be true, right? I'm actually have to be competing with all the others, try to submit my proof first. Right? I think that's kind of also solve one of the leading question in this domain. Say, hey, who is paying for the ZK proving cost? Because again, right, it is still not cheap in general sense. Yeah, I think that's basically kind of go over the whole what is a ZK coprocessor and what sets Brevis different, and how Brevis work with EigenLayer, and basically run this in hybrid mode. As a dApp developer, you benefit from both. One, you benefit from the optimistic path that cosign that has give you faster result and a lower cost. And also, on the other side, you are not compromising on any of the trust free, because there is always the watchers looking at all the cosign results from the EigenLayer operators and willing to submit the proof and claim the slash token whenever they can. So basically, the correctness is always guaranteed by the ZK part. Yeah, I think if you are interested to learn more, we have all this, in much more details, especially in the challenge flow time window on our website on docs.brevis.network. And next, I think I will try to use a few minutes. I'm not sure if you still need good ideas in general, but I'm just trying to kind of give you a new perspective. Now think about that. Before, beat DeFi, beat all the other DID or AA solutions, they have been, the on-chain smart contract has always limited by the what data is available, right, to your smart contract when it gets executed. But now with ZK coprocessor, we basically extend the data access horizon, time horizon to Genesis, right, to block 0, right? You can literally ask if this address has some is since the beginning, right? So questions like that. And also, you are no longer limited by the data available within the same chain, right? So we actually got partners deploy DEX on different chains. They routinely run into this fragmented liquidity and user issue, right? So even say some user already is a big liquidity provider on like Polygon, whatever, Binance, BSC, right? And then when they spin a new DEX, how they kind of give those users a proper like recognition or reward incentive, right? Before it can only be done manually in a very centralized way. Basically, within your smart contract, they have to have something only admin or only owner, which looks really better. I think now with the ZK coprocessor, the new use cases have been enabled so that the users can self-claim. So basically, they can say, look, here is my activities on another chain or on another environment or even on different projects, right? If you want to attract big players from your competing projects, you can say, hey, if you have done something on the other projects, I will give you recognition and welcome to join us, right? All those things today can be done in a trust-free way with the ZK proof, right? And of course, most of the money is still in DeFi, so I might dig a little bit deeper into the I talked about the Uniswap partnership, and also we are working with all the leading DeFi protocols. Their main point, right? Of course, the user loyalty is obvious. Everyone immediately gets it. But the other part is what they can do within the smart contract compared to, you say, traditional financial systems is still very limited. But now, at least we're getting closer, right? So because with all this ZK verified historical data and the computation based on historical data, you can enable more behavior tailored use cases. It's more like we in general we just call data driven, right? You can look at if some LP has always been doing like be a good helper, basically leave the liquidity in the pool no matter what, versus some other LPs who are doing just in time liquidity. Whenever they realize, oh, there's so much volatility, they will withdraw the liquidity, which actually hurts the protocol, right? But today they do not get the good behaviors and the, I wouldn't say call bad, but the people who playing tricks, they are treated the same. There's no way to differentiate it between the behavior you want to encourage and at least give some, I wouldn't say punishment, but lower the reward if someone like trying to game the system, right? But today, because when you run the smart contract, you only know what's current, right? You don't even know what's past the 128 blocks. you don't even see that. So with data-driven DeFi, basically what we are enabling with the protocols, the DEX protocols, they can be much more, I would say, particular about, these are the behaviors we want to encourage. And then you can actually implement this to give the proper reward, or even reduce the reward if they do not behave as encouraged, right? So that's kind of the new use cases we are really excited about. Again, remember I mentioned earlier, we are not looking at let's double the TPS or reduce that's not our main focus. What we are trying to say here is that, look, this is a new paradigm. By giving a trust-free data access for the entire history of any blockchain, your smart contract today can finally be smart, right? It's no longer dumb, like without knowing anything else has ever happened. But now it finally can. And there is of course, the Trust Lab. We launched a partnership with Trust Labs on the user behavior analytics, right? Basically, based on what this address or the user has done, they compute a reputation score. Right? This gives more, kind of opens a new. It's just like how the credit score in modern society is so critical, right? It affects every piece of your lending, and everyone over 18 knows you have to be careful with your credit score, otherwise your life will be very miserable, right? But in blockchain space, I think it's still kind of a new area. Many projects are very excited about that and try to find a new way. If you think about that, the requirement is we need to do the first step is, of course, the data part, and then the second step is you could have your machine learning or fancy algorithm to compute a score, just like Trust Labs working with us. I think they call it ZK. I forgot what's the marketing term for it, but it's something to do with machine learning. ZK media score or ML media score. And with that score, think about all the lending protocol, right? You could have a lower collateral. Yeah, it could still, in practical term, it still be over collateralized, but the ratio could be significantly lower, right? For like more reputable, with good reputation, with higher score. And also for the new projects try to onboard new users, all of them will welcome real, loyalty users instead of bots, right? And this actually give them a very easy way to say, hey, this address seems to be like either brand new or from its past behavior, it's all doing those like airdrop activities. It doesn't look like a real user, right? It's more like, say, a profit-seeking bots, right? I think those kind of the use cases, again, enabled by ZK coprocessor, especially with Brevis, we have seen very quick adoption, because once you have this score, you can easily extend to all the other projects. It's more like people can universally say, hey, this is a score, and I don't need to trust some third party for this number, because end-to-end, it's generated from verified on-chain data, and also the final result is verified by the ZK proof. Yeah, I think, of course, right, I understand maybe you don't need new ideas, or you already have your next $1 billion ideas ready. You just need to look for some like how you can actually leverage in this underlying infrastructure, right? I think overall our documentation is pretty well written. I remember at Denver, there are 2 teams in like only within 3 days. One did leveraging Brevis did a cross-chain, omni-chain governance, because you need to prove my voting stake on chain A and use that on chain B. And the other did something really fancy. It's like option trading. Let me remember. It's actually for me even a little bit harder to understand. They did option trading. The trading algorithm is written in ZK circuit, and the data, instead of depending on Oracle, they directly get from the on-chain, the price, right, from the contract. I think that's kind of the power with our SDK. Developer first only need to figure out what are the piece of data they want to access and what are the computation they want to do, and then integrate the end-to-end Brevis. And of course, now we have the partnership with EigenLayer. Even if you say, hey, I'm just doing some air job, it doesn't worth that much, you can still benefit from the low cost brought by the the EigenLayer operator committee. Yeah. Okay. I think that's pretty much. Feel free to follow our Twitter, and I think we have all kind of the regular channels, and we're also going out to different hackathons. And I think just last week we worked with EigenLayer directly. They call Infinity Layers to give their developers another round of introduction. Yeah. Okay. I think
amazing.
That's all for my talk. I saw there are several questions already.
Yes, I for everyone who's not here, it's always nice to ask them out loud. So if you don't mind, Junda, I'll read them out, and then if you can do your best to answer, that would be very helpful. So we'll start with James, who asks, what is the easiest way to reason about how much it would cost to use Brevis coprocessor?
Okay, yeah, that's actually a very good question. So like I mentioned, Brevis has, you can think about Brevis has two modes, right? One is a pure ZK. It's like every single piece of data you pass in, you say, give me a ZK proof for that. And that, if you check my slide earlier, in the production ready part, this is the number, right? So it with user, we are looking at end-to-end cost, including the final on-chain verification, is around $5 to $10. Of course, we are trying to do more underlying, proof aggregation. So it doesn't scale linearly. It's not like, say, if you do 10,000, there will be 10 times more. But on a high level, there are some fixed costs, right? And then there is how fast do you need this data? Because if you really need it, say, within 10 or 20 seconds, we have to spin more underlying hardware resources like GPUs to generating the proof. I think for if you say I only need one single say receipt, end-to-end cost amortizes about $1. Yeah, I think that's kind of it, because there are some fixed cost there. Like when we finally submit it on-chain, right, we have to pay the on-chain gas cost no matter what. I'm not saying that if you do 1,000, it will be $1,000, right? 1,000 transaction, that's the number we show here. $1,000 only costs like double, right? $2, because we aggregate on the line. So that's a little bit tricky. There's like, you can think about it like, what's the traditional linear, AX plus B, right? The B is there close to $1, and then the per transaction or per data points is, I would say, a couple of cents at most, for each data point. I think that's also the benefit. We didn't, at least for now, the existing ZK VM or DSL solutions are just not performant or efficient enough. So we handcrafted on all the underlying ZK circuits to gain the performance lead. Yeah. And of course, it translates to cost saving for the partners. Yeah.
Awesome. Thank you very much. And then Geeta asks about the dispute period and whether it's similar to optimistic rollups.
Let me go to that slide. Yeah. Optimistic rollup, because they do not, in pure optimistic sense, there is no final judgment, right? Because you have to depend on this long enough challenge window, and your final defense is the window is long enough, so challengers will submit a challenge. But in our case, it's not, right? This actually depends on different applications. Say, for example, I mentioned earlier, this window is actually dApp adjustable. So you are working as, I will give a different user a different NFT based on their, say, number of transactions, whatever. And it's up to the developer to decide how bad it is if I get it wrong, right? If you say I'm just giving it one more NFT and it doesn't, that could be then you can reduce the window to get more liveness. And of course, remember, if ZK can prove the result is wrong, it's up to the dApp developer to decide, do you revoke it or just say leave it as is, right? So basically, that's kind of the trade-off. We leave it as a choice to dApp developers. As a project, we have the final underlying slashing window that's pretty large, but it doesn't affect you don't have to, as an app, you do not need to wait until the final, because you can already use your own timeline or timer to say, after say half an hour if it's good, or even after 1 minute, I'm okay to use the result, right? So the thing here is that different projects, say if it's a bridge, it might be more cautious about, right, how this another thing happened has been proven. But if it's something inherently doesn't carry too much value, they can go with much shorter, what we say here, application specified window, right? And the underlying Brevis is in days. The challenge window is in days. The co-translation window is in days. But it doesn't affect, it doesn't mean the application need to wait. The application can just say, I don't even need to wait. You can set your application specified window to 0 and it still works, right? Because the underlying the Brevis system will guarantee if there are some incorrect results, it will be overwritten by the correct ZK proof. So I think that's kind of I remember last year when I was at Paris, in one of the layer 2 rollup panel, the optimistic and the ZK rollups, the final I would say conclusion seemed to be they were joined forces, right? Become a hybrid mode. This is similar to what Brevis is doing. So we have the optimistic path, and then we have the ZK as a kind of your trust-free guarantee the data is correct.
Amazing, thank you. And then I guess looking at the time, one final one, we'll go to Satya, who asks, what kind of machine learning models can Brevis support, and are there any quantization constraints?
Yes, so if you are interested, you can look more into our blog post and announcement with Trust Labs. I would say for now, right, many people talking about ZK ML, but ZK already makes the problem like 1 million times harder. And machine learning depends on which you are talking about, because now AI and ML is more like overloaded term. Everyone has their own definition. For the simple UDFs, basically, I would say a more advanced data analytics, we can support that. Right? It's all about what the use cases are. But if you say, hey, I want to run a large language model in there, I think we're not there yet. So I think that's I want to be very specific. We don't want to get like over promise something that's not ready yet, because there are two fundamental issues, right? Number one, of course, is the scale, right? Remember, with the existing computation, you can think about every time you add ZK, in the best case, is still 100,000 or even 1 million times more expensive or slower, or incur the underlying cost in there. So if today the problem requires NVIDIA's best GPUs, you times 1 million, that's just not there yet. The hope is with the new zero knowledge proving algorithm and the framework coming out almost every month, we are keep reducing that 1 million overhead. We are looking at maybe 100,000 or even 10,000 in a few years. Then that could be more approachable, right? Maybe in 2 years also you can run a simple like a smaller large language model. But today, right now, not yet. And the other part is for all those fancy language models, they have a built-in, how do you call it, randomization, right? So basically, it's not like you ask the same question, they will give you a different answer every time. But that actually counters the whole ZK logic, right? Remember, ZK needs everything to be precisely working, repeatable, so that every time you run the circuit, it gives you the same result and generate the proof. But if you say, hey, for the same input, the black box will generate different results different time. That's, I would say, is still a leading research question in the ZK community. How do we even handle that? Within the team, we have something really exciting to share, hopefully in, I think in 1 or 2 months. It's still work in progress, so I don't want to spoil the surprise. But the promise here is that, one, with the new thing, hopefully in 1 or 2 months, we'll announce something that's very exciting to basically say, yes, we within this frame, or like the problems the machine learning problem we can handle, the overhead is much significantly lower, so we can enable more machine learning models. Yeah, I would say for now you can at least start with your own user-defined, UDFs to start get the taste of it. Right?
Amazing. Well, I think that teaser is as good of a place as any to end. So I think we're up on time. We'll wrap things up there. But Junda, thank you very much for joining us today. A really incredible session, and I know the participants will take a lot away from it. You shared a slide to your Twitter. Do you want to quickly navigate to that now, and we can just leave that on the screen?
Yes.
Is Twitter the best place for people to follow you and find out more?
I think the again, right, so I would say you might already realize Brevis as a team, as a project, isn't necessarily direct to end consumer and user. It's more like work with partner projects, work with developers, right? So yeah,
sure.
Feel free to follow us and ask questions. Yeah,
sure. Awesome. Well, everyone get your phones out, scan that code, and head over to the Twitter. I see everyone saying thank you in the chat as well.
Thank you.
Thank you, Junda, and we'll see you all again tomorrow.